This video will go over mole conversions. It will cover what a mole is, why they are important, how to use the mole highway, and an example step by step. A mole can be described as the unit of amount in chemistry. 1 mole of any element is equal to 6.022 times 10 to the 23rd things or atoms or molecules depending on the substance. That constant is known as Avogadro's number, or Avogadro's constant, and is based off of carbon-12. Moles give us a tangible number to grasp in terms of how many particles are in a sample. So depending on the element or compound, 1 mole of substance X can have a much greater mass than 1 mole of substance Y, but have the same number of particles. This is where mole conversions come into play. When I say mole conversions, I mean the process of converting different units to and from moles. Given the mass of a substance, usually in grams, one is able to convert that mass to moles and even further to the amount of particles in the sample, and back. These conversions allow for stoichiometric problem solving. For example, to determine the limiting reactant or calculate the theoretical yield in a chemical reaction. In order to convert between moles, grams, and particles, it is important to understand molar mass. Think of molar mass as a conversion factor. To calculate molar mass, we look at the periodic table. For single lone elemental compounds, the molar mass is equal to the atomic mass. For instance, chlorine's molar mass is 35.45 grams per mole. For multi-elemental compounds, the molar mass is equal to all the elements' atomic masses added up. To give an example, the molar mass of water, or H2O, is hydrogen's atomic mass times 2, since there are 2 hydrogen atoms, plus oxygen's atomic mass, making water's molar mass 18.02 grams per mole. The mole highway summarizes the essence of mole conversions. Depending on what is given, we can follow the highway and arrive at the desired unit, whether that be grams, moles, or particles. To go from grams to moles, divide the mass given by the sample's molar mass, and the reverse to go from moles to grams. Looking at the right side of the diagram, you can see the steps necessary to convert between particles and moles using Avogadro's number. The interesting thing about the mole highway is you can go back and forth, and depending on what is given, you can solve for whether it be grams, moles, or particles. Now, to sum up all we have gone over, let's practice a mole conversion. The question asks, how many moles of water are in 24.3 grams of water? The best way to approach these types of problems is to set up dimensional analysis. We are given grams and are asked to convert them to moles. Remember, the mole highway states to go from moles to grams, we must divide the mass by the molar mass. So 24.3 grams can be written divided by its molar mass, 18.02. It is always important to include units as it minimizes error. So the answer should be 1.34 moles. To go even further, we are able to convert the amount of moles we found to particles, or in this case, molecules, since water is comprised of molecules. To do this, we must multiply the moles by Avogadro's number. So, 1.34 moles times 6.022 times 10 to the 23rd. This should give us an answer of 8.07 times 10 to the 23rd molecules, an enormous and basically intangible value. I hope this video helped, and thank you for watching.